Welcome, everyone. Thank you so much again for joining us for our 5th session that is focused on OA Africa. Ocean Acidification Week is presented by the Global Ocean Acidification Observing Network, or GOA-ON. Also in partnership with NOAA, the National Oceanic and Atmospheric Administration, the IAEA, OAICC, IOC-UNESCO, and we are looking forward to featuring talks from around the continent of Africa today. We are so glad to have over 165 people pre-registered for today's session. My name is Jennifer Mintz, and I work with the NOAA Ocean Acidification Program and will be moderating today's session. During the presentation, all participants are in listen-only mode. You are welcome to type any questions you have for our speakers into the questions box, which can be found at the bottom of the control panel on the right-hand side of your screen. You can also pose questions and share your insights or ahas on Twitter using the hashtag OAWeek2020. We do ask that if you are posing a question for our speakers, please let us know who you're directing that question to. We'll be monitoring those questions and we'll pose them to our speakers during the question and answer session, which will begin immediately after the final presentation of today. Today's webinar is being recorded and will be available on the GOA-ON YouTube channel shortly after this virtual event ends. Before we hear from our speakers, I would like to just briefly share about GOA-ON. So GOA-ON, the Global Ocean Acidification Network, is a collaborative international network that is aimed at addressing 3 goals: to improve our understanding of global ocean acidification, improve our understanding of ecosystem response to OA, and acquire and exchange data and knowledge necessary to optimize modeling for ocean acidification and its impacts. GOA-ON is an active organization that offers numerous resources to its members. GOA-ON informs policy at the international level. GOA-ON is involved with the Commonwealth Blue Charter and the UN Decade of Ocean Science for Sustainable Development. GOA-ON also assists with the UN Sustainable Development Goal 14 by helping to develop the methodology for this goal's indicator 14.3.1 by providing guidance on how to measure ocean acidity and how to report the collected information. GOA-ON also offers a scientific mentorship program called the Peer-to-Peer program. And this program matches senior researchers with early career scientists to facilitate an exchange of expertise and to provide a platform for international collaborations. Scholarships and hands-on training are also available through peer-to-peer. GOA-ON also hosts a data portal, which provides access and visualization to OA data and data synthesis products being collected around the world. Data are present from a wide range of sources, including moorings, research cruises, and fixed time series stations. Finally, and most recently, OA Week is the kickoff to GOA-ON's new webinar series. Future webinars will take place every 4 to 6 weeks, and we welcome your input on how or who you'd like to see, the topics you'd like to see discussed in future GOA-ON webinars. Please type any of those ideas into the questions box so we can be sure to allow those to inform our future webinar series. GOA-ON has 8 regional hubs, and we will be hearing from most of them throughout Ocean Acidification Week. Overall, GOA-ON has over 750 members from 100 countries, and you can become a GOA-ON member by visiting the website goaon.org. One reason why GOA-ON decided to host OA Week is because initially the 5th International Symposium on the Ocean in a High CO2 World was scheduled to take place this week in Lima, Peru. Yet, like many other events scheduled for this year, the symposium has been postponed until 2021 because of the COVID-19 pandemic. This symposium would have brought together researchers, decision makers, and other stakeholders to share cutting-edge ocean acidification science. And we're looking forward to that and hope everyone listening today will visit the symposium website and learn more. We are fortunate today to hear from a great list of speakers. And we'll first be opening with Karen, who will give us a brief introduction on the OA Africa Hub. So Karen, I will hand it over to you now.
Hi, I think there's a mistake. Is it?
Oh, sorry, Karen, I will not hand it to you. I will hand it to Naira. Apologies.
No problem. Hello, everybody. I will present today a short speech describing Ocean Acidification African Hub. I'm Naira Shaltut. I'm an associate professor from National Institute of Oceanography and Fisheries, and I have the honor to be a co-chair with my co-chairs Roshan from Mauritius and Shak Sharif from Liberia. Okay, I will give you a very, very short and fast brief regarding OA Africa. We started OA Africa Hub in 2015 after the workshop that's held and funded by IAEA, and it was to ensure that Africa is resilient and knowledgeable about potential threat of ocean acidification, and it is a network of scientists that working together to provide information and guidance to stakeholders and policymakers. And the second aim is to coordinate activities related to ocean acidification research and monitoring activities, and identify a broad support for OA research along Africa. Our goal was to help and coordinate and set regional priorities for monitoring and research designed to further our understanding of coastal acidification along the African coastal area, identify the gaps in understanding of the scientific and socioeconomic of ocean and coastal acidification impacts on Africa, communicate and facilitate exchange of knowledge to relevant stakeholders and funding agency, respond to stakeholders' needs, increase the scientific capacity, and ensure quality data generation. This is how we grown up from 2012 to 2020. This is how the awareness of the impact of ocean acidification raised in Africa by the cooperation of different funding agencies of ocean acidification, GOA-ON, funding of Ocean Foundation, Future Earth, IEA, and UNESCO, IOC-UNESCO. So this is the increasing of the involvement and engaging of African countries. Why OA Hub interesting in raising this awareness for stakeholders and scientists and increasing the research along Africa? Because the coastal, it's a very important topic and aspects for African researchers from the scientific-wise and the economy-wise. Coastal and ocean systems are important for the economies of the livelihood of African countries, especially, and in addition, climate change and ocean acidification will increase the challenges from the existing stressors in Africa. These stressors were overexploration of resources, habitat degradation along the coastal area along Africa, loss of biodiversity, salvinization, pollution, and coastal erosion, which maximized and duplicated when it's coupled with ocean acidification and climate. What the activity is organized by our funding agency, IEA, OAICC, GOA-ON, Global Ocean Acidification Observing Network, WIOMSA, which played a very big role in East Africa, SOLAS, the Ocean Foundation, and Intergovernmental Oceanographic Commission of UNESCO, and EMBER, Future Earth. They worked for and allocated funds for capacity building activities, such as training, basic chemistry, basic biology, advanced training, and providing kits and deployment of sensors, funding project, mentor and mentee program. This is some examples of some capacity building programs training that took time from 2015 till 2019 in Cape Town, in Mozambique, in Dakar in 2017.
It appears we may have lost connection with Naira. We'll give it just another few seconds to see if perhaps we can reconnect. Yes. So it looks like we have lost Naira. We'll go ahead and allow, we'll continue with today's presentations and let Naira bring us home after these presentations before our Q&A. So Roshan, if it's okay with you, I will hand it over to you.
Okay, thank you very much, Jen. So I'll just... All right. So I hope you can see my screen. So more or less, as I said, Naira, myself and Sheikh, we are all co-chairs of OA Africa, and as I mentioned, I'm in 2015, where Naira just mentioned about the creation of the OA Africa hub in Cape Town. So down the line, we are now 25 years down the line, and as you can see, there's been quite some advancement in certain technologies, in terms of capacity building, in terms of methodologies which have been brought to this part of the world. And especially we're very happy because all of us as co-chairs in West Africa, in East Africa, in North Africa, we were asked to work with the 140 scientists, African scientists, to try to develop a white paper. And my presentation today, and obviously my colleague Kishore from the University of Mauritius, will talk about more of the methodologies, but I will try to give you an insight of how this white paper came about. And especially we were very happy to involve a number of countries in the East African region and a number of African scientists in various institutions in East Africa. So our first, just to mention, this was how it started with very basic equipment. Everyone was asked on the 8th of June of 2017 to take some pH measurements with whether it was very crude or, I mean, instruments, very basic field measurements, just to start the awareness of pH. And I mean, you can see it was done around the world. Africa, people measuring pH at probably 2 decimal places. I mean, these are just a few of the measurements where we started to get involved. Well, as I said, as Kirsty as well said, I mean, we were very fortunate to be able to attract funding from IOC-UNESCO to get a project, 6 projects involved in the East African regions. And especially we fall under the SDG goal 14.3, where it means it's to address impacts of ocean acidification. So there has been a number of workshops and meetings and capacity building following 2015, 2016, 2017. I mean, these are important dates in how OA Africa and OA ocean acidification was started, and especially we have the Africa project funded by the US State Department, Ocean Foundation, IAEA, an International Coordination Center for Ocean Acidification, trying to train people in capacity building and so on. That's what I will need to talk about. So you can see, especially there has been the goal SDG 14.3.1, which is the indicator methodology. I mean, I guess the pH is quite an important indicator which has been accepted under the United Nations, and this is where the 6 projects in the various countries, which I will come identify for you, we started giving a training to people and trying to give funding for start certain projects. So more or less, there are various dots here you can see, and all these have been located by GPS, and these are locations where pH and alkalinity is being measured, and certain biological and chemical experiments are being done. As I said, it's very important to know the chemistry before going into the biological response, but these are the 2 phases where these have to be linked in. So the 6 countries which have benefited from projects: Kenya, Mauritius, Mozambique, Seychelles, South Africa, and Tanzania. And the objectives of the initiative is to establish ocean acidification observation and research in the Western Indian Ocean to help countries to achieve the target 14.3, minimizing the impacts of ocean acidification. And also we benefit from IOC, UNESCO, and WIOMSA, and especially there has been a number of workshops under the Nairobi Convention, where, I mean, this has been started in 2017, workshops in East Africa, meetings to start to create this awareness, and especially to build and create a community of practice in the Western Indian Ocean for ocean acidification and other stresses on marine environments. And as I said, it's very important because the white paper is to do with policy making, and whether we go in East Africa through the Nairobi Convention to try to make the science relevant to society, and also to relate the ocean acidification observation to species and ecosystems of socio-economic importance. So you can see the region where we've been working. This is the Western Indian Ocean, South Africa, Mozambique, Tanzania, Kenya, Mauritius, Seychelles, all of the 6 countries who are benefited in this endeavor of attracting funding and to have certain experiments. I would mention that we had a number of resource persons like Sam Dupont, Andrew Dixon, Chris Sabin, Sophie Chu, even Alexis from the Ocean Foundation, visiting various countries, twice in Mauritius, Madagascar, even in Tanzania, Zanzibar, or Kenya at the Kemprey Institute, just to give capacity building in terms of biological experimentations or simple chemistry analytical techniques. So, as I said, this is the regional program, and it all fits. We have the workshops for the Western Indian Ocean in October 2017, organized by WAMSA, especially in collaboration with IOC-UNESCO, and also Global Ocean Acidification Observing Network, the IAEA Ocean Acidification International Coordination Center, and NOAA Ocean Acidification Program. And special sessions were held during the 11th WABSA Symposium in Mauritius, 2019, that was last year. We had also OA meetings with the 6 principal investigators who benefited from funding from IOC-UNESCO to start thinking about the projects, to start discussing in terms of various technologies or the certain experiments, and followed by a workshop in Zanzibar where a number of scientists, African scientists, were asked to join and to discuss. And it's all to provide information and to get the networking ongoing. So as you see, this will provide critical information for adaptation to the changing ocean conditions and to meet the observing requirements of SDG 14.3.1 to provide information for the broader scope of 14.3. So also we're talking about whether it's climate or whether type of data. Well, at the moment in East Africa or Africa, we are working with instruments which are, like ISAMIs, small weather type of data, and but eventually, hopefully, we can provide high quality data to the Global Ocean Acidification Observing Network and the portal as well. At the moment, I would mention that we are in Africa or even in Mauritius. We had capacity building. We had prototype ISAMIs sent by Sunburst from Montana, Jim Beck, and the first 4 prototypes we had capacity building with Chris Sabin from NOAA to start how to do the measurements, even some kind of troubleshooting, and especially we are also trying to do alkalinity measurements using open cell calculation and the standard operating procedures. Again, these were done at the Mauritius Oceanographic Institute in the labs there. So we are trying to create this committee of practice and especially trying on the next phase to bring in the biological experiments in certain of these countries as well. So here are some of the institutions who benefited for projects under IOC-UNESCO from March 2019 to December 2021. CAMFRE in strengthening of the national capacity for monitoring ocean carbon chemistry and its impacts. In terms of Mauritius, we have a joint collaboration with MOI, Mauritius Oceanographic Institute, in setting up the Oceanic Carbonic Chemistry Observatory in Mauritius waters, Ocean Acidification Initiative, Edworthy Monlane University in Mozambique, establishment of ocean acidification observation. Here we have the University of Seychelles with Jerome Harley, and ocean acidification observation and experiments in South Africa by the Oceanographic Research Institute. We have Dave coming with us today, right? And in Tanzania, it's the Tanzania Fisheries Research Institute with the project Ocean Acidification Observation in Tanzanian waters. So the recommendations, as I said, we started building this white paper probably 2 years, and we keep updating, and this is quite a very important document for us to keep track on how we go about and how to monitor the progress in terms of monitoring OA conditions, coastal waters, sharing data for the Global Ocean Acidification Network, how we evolve with biological and socio-economical vulnerabilities, and depending on these type of experiments, in terms of analysis of all species, how to reduce local sources of acidification, reduce other stresses to the marine environment, protect natural carbon sinks such as seagrass beds and mangroves, especially in coastal areas like in tropical areas in Mauritius or in various African countries. In terms of seafood production, whether we have shellfish fisheries, even exploring other seafood production. Well, in terms of regional capacity, we need to promote the understanding of OA trends and impacts, and also take advantage of the peer-to-peer program to work with other OA scientists from other countries who may want to assist. So just to mention, because I've been talking about various the timeline where we started with from 2015 to 2016 with the Africa project funded by US State Department and the Ocean Foundation. 2017 we had Chris Sabin coming to Mauritius, applied training course. We had Sam Dupont in 2016 and Andrew Dixon in Mauritius. We even had this workshop where we invited scientists who were funded by the IAEA, from various places to start getting these training courses. And we also had the kit, the GOA box kit, sent to Mauritius. So there were 2 given to Mauritius, 1 in Mozambique, 1 in South Africa as well. And that's where from March 2019, we had 6 WAMSA IOC project funded in East Africa. So more or less, here I'm just giving you some of the sampling strategies in terms of using ISAMIs. These are still prototype, and probably Kishore will explain to you more because we just acquired under WAMSA funding 2 ISAMIs just sent to Mauritius a month back. So we are experimenting with the 2 new units where there has been a number of updates in terms of softwares, in terms of instrumentation, and so on. And these are things that there has been quite a big improvement, because from the various sessions which I've heard from the Pacific region, there are certain troubleshooting which needs to be done in terms of batteries, in terms of communications, in terms of various cables, which are in terms of transfer of data from the sensors to the computer and so on. So maybe Kishore will talk more about that. So these are the stations under the WAMSA IOC project. We have 4 coastal stations, 1 on the East Coast and two on the East Coast and 2 on the West Coast. And there are MOIs involved with monitoring in 5 kilometers offshore, and there are 2 offshore stations. So the basic techniques which we are using ISAMI, spectrophotometric methods, and open cell calculation, where we are measuring a number of parameters in this project. So just to give you an idea of some of the measurements which we've been doing in terms of spectrophotometric determination, we're using the device at Albion, where samples were collected in special bottles under Tigan tubing and so on. So these are research assistants who were employed at the university to collect samples and to do the pH and the spectrophotometric determination. And here, this is the new unit, and you can see Kishore here trying to download some of the data. And we've been in contact with Chimbeck and Sunburst, trying to find solutions and trying to understand how the transfer is being done and how what is the quality control with the data and so on. And as I said, I mean, these are all various steps in trying to measure the pH with the ISAMIs as well. And here is just discrete samples with ISAMI, which we've been using the prototype midday, trying to check on some of these measurements. Obviously, we could have got more time series, but usually we go in the field for 4 hours, but we don't want to leave the equipment for a whole day, but it's all, we can program it for probably a month or depending on battery life, but it's all over security. But here are just average values in terms of pH. And in terms of alkalinity, this is the equipment we use for alkalinity, with the voltmeter, with the probes. Obviously, I heard in South Pacific, in Pacific regions, they have problems with the probes because it has a lifetime. So these are all maintenance type of things that needs to be done in trying to measure some of these parameters as well. So this here is just a sum of the values we determine in 2 of the coastal regions in Africa in terms of open cell filtration, so on. So as I said, it's very important to understand ocean acidification, because we need to characterize the chemistry behind it, and especially we need to have quality control data, because these are very important. But as you can see, I mean, if you are doing biological experiments, probably some will talk about that. Well, it's all to do with experiments with biological organisms, where you just need to, well, it's instruments that can be used to control the pH in certain experiments. So we all fit in here. As I said, we have international action, and as I said, we've been it's very important that we learn from various projects in different places, because we are just starting ocean acidification research and capacity building in the East African region, and hopefully in West Africa or North Africa. These are steps which could be followed. We have a number of scientists who are there and trying to understand these. I mean, try to get the transfer of technology right. And I guess the Ocean Foundation had a meeting or a virtual conference in West Africa probably a month back to talk about some of the methods and even technologies which can be used. So as you can see, it's all to do with protection of carbon sinks, local sources of acidification, especially in coastal regions. Especially, we had a major oil spill in the southeast of the island where we had the Wakachio tanker. It's all I mean, the southeast at the moment is a restricted zone in Mauritius at the moment. But it's all to do with coral reefs and how this will change. In terms, I've been watching the Arctic region. We're talking about water, freshwater inputs, how it affects the pH in terms of organic debris and so on. I mean, all has to be linked all together. So, as you can see, I mean, there are measures which needs to be taken in terms of exploring other seafood production options, or building capacity, or implementation and development of renewable energies and low carbon technologies. So the Ocean Acidification Information Exchange is a very important portal where you can engage, address, and share conversation with various scientists in various places. And this is where scientists are encouraged to join this portal. And acknowledgements to GOA-ON and so on, everyone here. IOC-UNESCO, the Ocean Foundation, even OA Africa as well for mentoring and to follow up with our activities. So more or less, I think that's the end for me. Thank you very much.
Thank you, Roshan, for giving us some insight into the efforts in East Africa. We will now hand it over to Kishore. It should be coming your way. Things look great, Kishore, and if you'd like to hop on video, you're welcome to. Wonderful.
Sure. Okay, so hello to everybody, and greetings from Mauritius, because I know we've got different time scale here. So to start with, oops, sorry for this, yeah. You can see that the title of my talk is Ocean Acidification for Investigation for pH and Alkalinity in Coastal Lagoons in Mauritius. And I'm Kishore Boodhoo. In fact, it's Dr. Ramessur who's come up with this Environmental and Coastal Sciences and Ocean Acidification Research Group, which falls under the Polar Research at the University of Mauritius. Okay, so we've got our email addresses there, which is ramessur@uom.ac.nu, and mine as well. So we'll be happy to get in touch with everybody, because after all, we belong to the same OA family, isn't it? So. Okay, so where did it all start? So, in fact, there was this workshop initiated in Mauritius by the GOA-ON, the Ocean Foundation, IAEA, and NOAA. That was back in 2016. From there, we were provided with the first ISAM-APS prototype that was manufactured by the Sunburst Sensors based in the US. We're also given an open cell titrator together with its accessories, and that's been donated by Chris Sabin's group, who is based on a cruise vessel in the US. From there onwards, we've managed to secure a grant from WIOMSA for 3 years, and the amount we got is like 44,500 USD, and the work started from March 2019, and so to say, it's supposed to end till December 2021, but due to COVID-19 pandemic. So we would like to have some more extension from there onwards. The objectives, sorry for this. Sorry. Nope. Sorry, start again. Sorry for this. Yeah, the objectives of the study was to determine the pH in a closed system. When I mean closed system means it's simply a lagoon within the reefs using UVV spectrophotometric method and from the deployment of the pH sensor. The other objective is to compare pH values obtained from the UVV's experiment and the ISAMI pH sensor. The third one is to determine the total alkalinity at that sample site, and of course to observe the seasonal variation in pH and alkalinity recorded in coastal lagoons and the open sea. Okay. The other step we would like to go ahead with is to recruit an MPhil PhD student and some other research assistants. Okay, just a few words on the Republic of Mauritius. You can see it lies on the east of Madagascar, just here. Okay, everybody can see that, I guess. So it is a very tiny island, but it is also referred to as an ocean state because the exclusive economic zone is like combining France and Germany together. And I have to say, within this area, there is not much data on ocean acidification. But for the time being, we are based on the western coast of Mauritius, which is here on that smaller map when it comes to the island. And right, and that's the Silicon Flag Lagoon. That's where we are based, and you can see here that's where we are submerging our ISAMI pH sensor, and we're collecting samples for analysis in the lab. Okay, so the dates like where we've done sampling and the deployment of the sensor. It started from June 2017 to April 2018, and from November 2018 to May 2019, both projects, both projects were funded by the by the Ocean Foundation. Okay, but for the YOMSA project, it started from August 2019 until February 2020. Why? Because we had to stop because of COVID-19 pandemic. And the works resumed as from July 2020, and we're still doing it. Just some results for the pH recorded using UVVis for Silicon Flag. You can see the variation here for the different dates from the year. Sorry. Technical problem. Yes, so you can see from the year 2017 to 2018 here, the pH variation, that's, and then for the year 2018 to 19, from 19 to 2022, the current thing. So in brief, we can say for the summer 2018, the pH varied from 8 to 8.2, and in 2019 summer again, that's from 7.87 to 7.96. And when I say summer here, it started from November till roughly March. And for the winter, it is in 2018, the pH values varied from 7.93 to 8.03. And in 2019, the pH varied from 7.91 to 7.96. And when we conducted t-test analysis on these summer and winter data, we've seen that the results were significant. It means that the pH, the trend of the pH in summer compared to winter is a little bit different. I think we have to expect that. Why? Because in winter, we expect more CO2 to dissolve in the seawater. Now, that's our famous ISAMI sensor. You can see it's being submerged. And as I said, I think it's being provided by Sunburst Sensors, by James Beck, and with it, His email address is jim@sunburstsensors.com. So if you compare the values of the pH recorded using the UV fish to that of the pH ISAMI, you can see they are closely related. For instance, the first one, it says 7.93, and then we got like 8.078 for the pH ISAMI. Again, 8.05 for the UV fish spectrophotometrically determined pH. And for the pH ISAMI, it's 7.9991. So you can see the values, they are close to each other. So in a way, this ISAMI sensor, because it's properly calibrated, is helping us to kind of do the quality control on our measurement when using UV spectrophotometry. Right. What's interesting about this sensor? It's equipped with this QC pH program, which has the ability to filter out outlying blanks and sample points that could have resulted from, let's say, from air bubbles that are being sucked in. Okay. It can also detect points where a mechanical error, such as a failed valve or bump, might have occurred. With this software, the QC pH will give a more reliable pH value, and when the data that we recorded on the sensor is going to be fed on this program, different graphs are generated that would be useful in determining the data quality and the instrument performance. Okay, for example, okay, you can see the plot on the right hand side and gives you the intensity absorbance plot. So the top plot, as you can see in the it gives you the reference signal, and it says it has to remain constant, and this is so when we look at the graph here. But what is most interesting here, you can see the spikes here, these two spikes. So what does it do, the QC control? It's going to smoothen the curves. Can you see this? So that's why I'm saying it's going to give more reliable results. Okay. Furthermore, you can see blank plots are being generated. What this means is, because normally when we add the dye, which is the metacrystal purple to seawater, we've got two peaks on the UV spectrum. The first one is at 434 nanometers, and the other one is at 578 nanometers. And that's why we've got two lines here for the blanks, each representing the two wavelengths. Right. One more feature is the flags plot, which will tell you where the fault might have occurred. For instance, you can see here 1, 2, 3, and 4. Let's say if there would have been flags on 1, it will tell you that the blank value was not consistent from the other blanks, and therefore the pH measured could be erroneous. But here, for instance, let's say we've got this one here, flag. There's a flag at on 4, and this indicates that at least one point during the measurement was an outlier. What does it mean? It could be that air bubble have been sucked in while being deployed. Okay, so the good thing is, it says here, the software will throw the outlier, yes. So this flag does not necessarily indicate an erroneous pH measurement. So this is quite good. Now, this is a very important feature on this program, because look, when it calculates the final pH, in fact, it is working in such a way to remove that slight acidity brought in by the dye to the seawater. So therefore, it says the final pH is an extrapolation of point pH against the total indicator concentration to the pH at the 0 indicators. Therefore, we are here having a pH of true seawater when deployed. So now we're moving to the other part of the experiment, which is the open cell titration. In other words, we're determining alkalinity. Here we can see we've got the voltmeter, and that's our open cell titration. Looks very simple. We've got a water jacketed beaker, and that's the probe we're using. In fact, we have to use the metro-ohm pH electrode, because that will give us a more precise measurement for the signal being recorded. We've got the mechanical dispenser, and the titration involves the seawater being titrated with HCl solution. Okay, right. So alkalinity is simply a concentration of bicarbonate being added to twice the amount of carbonate concentration, and from this you have to subtract the concentration of the acid being added. So this is very useful in determining the buffer capacity of seawater. In 2018, we've seen that the alkalinity varied from 2100 till 2400, whereas in 2019, the alkalinity varied from 2300 to 2700. So this falls, let's say, roughly around 2500, which is the estimated alkalinity for seawater. Right, just a few more graphs here, which shows the variation of total alkalinity with time over the years. Okay, so in fact, you can see working at two sites here, Flic-en-Flac and Albion. And again, as I said, Flic-en-Flac is on the west coast. Albion is simply on the slightly higher up, northwest of Mauritius. Some more graphs. Again, on the same day here, we can see at Flic-en-Flac, we've got the variation of total alkalinity, which is roughly constant. It's good news. And pH equally the same thing, because it seems it's going up, but it's not in fact, because it varies from 7.95 to 8, so very minor change. For Albion, similarly, not much variation in there during the same day. Right, with that, I think I've been pretty quick. So I would like to thank the Ocean Foundation, the US Embassy, the IEAE, GOA-ON, NOAA, and the University of Mauritius for organizing the workshop on OA and providing equipment and funds. YUMSA for generously providing us with a research grant to continue with the work on OA. As I said, it's for 3 years. And a special thanks go out to Professor Dixon, who is our mentor.
Thank you, Kishore.
Yes, just one. This is, sorry for this, this is Dr. Ramessur. That's Mr. Rajan Venkatasamy, who would accompany us all the time for the sampling. That's me. And with that, I would like to thank you all for your attention.
Yep. Thank you, Kishore. As I hand this over to Dave, I will just ask all of the panelists, the remaining speakers, to check in the chat box. And Dave, I hope things are coming over to you.
Yeah. Can you see?
We're getting there. Yep. Let's see. Waiting on the presentation.
Okay. Should be. Can you see that? Okay.
There we go.
Hi. Okay.
Perfect.
Yeah.
And you have the option for video if you like.
Okay. Thank you very much for the opportunity to present today. I'll try and make this short and sweet. I know we're running a little bit behind. So I'm going to present work from two groups, the Oceanographic Research Institute and SciAb in consultation with SAON, with Carla Edworthy's work, who's been generous to provide me with some of her data she can't present today. So South Africa is uniquely situated at the tip of the continent and bordered by two oceans with very, very different characteristics. Much of South Africa's unique oceanographic features, both biophysical and biological, are driven by two major currents. The warm Agulhas current on the east coast and the cold Benguela current coming up from the Arctic and the associated upwellings on the west coast. This physical complexity has resulted in a corresponding wealth of biodiversity, ranging from subtropical corals in the northeast to nutrient-rich cold water ecosystems in the west. And this is just the coastal regions. There are other physical features such as the Agulhas bank, etc., that all contribute to the extreme richness of the biodiversity and physical oceanography of the region. I'm going to describe First, some work done in the East Coast, in the Delagoa bioregion by Ori, and then in the Agulhas bioregion by Carla and Carla Edworthy. So the Delagoa bioregion is characterized by high latitude coral reefs. These are high biodiversity reefs that are located at the edge of coral distribution and are considered to be marginal and non-accretive, even though they are very species rich with over 150 odd types of hard and soft coral. They have a high proportion of soft corals and are split in, and the reefs in South Africa are split into 3 complexes: the northern complex, central, and southern. Biogeochemically, these reefs undergo both seasonal and sporadic fluctuations in temperature, salinity, and pH. And these can include rapid cooling events. This is over the course of a half a day or so, a drop of 6 degrees centigrade, driven by upwellings. And these are possibly driven by mesoscale eddies, as well as by wind and other events. Prior to COVID, as part of the WIOMSA IAEA OA process, we were in the process of setting up a pH monitoring station to look at pH and other parameters using our CFOX. And unfortunately, this was kind of put on hold for a bit during the epidemic when we weren't allowed to leave our houses and go into the field. But we're planning to get this up and running as soon as possible. We've been lucky enough to put it in our aquarium so that we can troubleshoot before we get it down. We're also planning to look at carbonate-driven processes on the reef, such as accretion and dissolution, through in situ experiments. And this is going to plug into the observations and enable modeling of future accretion, dissolution dynamics on the reef, which are critical for coral reef processes. We're also using lab-based experiments to determine the physiological responses of critical reef organisms, such as corals, to ocean acidification in combination with other stresses, such as warming. So this is an example of an experiment that we have run in the past, which is looking at a cross experiment between temperature and pH. And in this case, we see that both temperature and pH have an effect. Temperature has quite a suppressive effect on growth of this particular coral. But the interaction, interestingly enough, the interaction between temperature and pH is much less strong, much less important than the individual effects of temperature and pH. And if we look at the way the corals respond transcriptionally, you can see that there's quite a few RNAs that are regulated differentially by temperature and by pH, and only a minority that are held in common. So that fits with the previous data. A similar effect is seen with fertilization, where you see some differences in temperature and pH, and they don't seem to cross-react at all. This is work by Justin Hart. In the Agulhas region, Carla Edworthy has been working with SIAB, the South African Institute for Biodiversity, Aquatic Biodiversity, and SAON, the South African Earth Observation Network. And Carla's been working on the Algoa Bay Sentinel site. This is part of the SMACRE program run by SION. And they've been testing monthly and daily pH and associated measurements such as chlorophyll, temperature, etc., around the Algoa Bay region. So they have a number of inshore and offshore sites where they have been doing monthly and then 24-hour long deployments. So if we look at the monthly changes in pH, you can see that while the average pH remains is in the same range, the temporal and spatial dynamics are different. So there are multiple drivers, there appear to be multiple drivers of variability across both the inshore and offshore sites, and that there's clear, complex local modulation of pH that varies over space and time. On a more fine scale, when we look at the diurnal pH, we see a clear variability over the course of a 24-hour period with changes of up to 0.56 pH units, which is significant and positively correlated with the temperature, and this is potentially driven by biological activity. When we look at these sites on a spatial level, we see that there's clear spatial variability and that there's a consistently high pH in this site number 1 here, which is on the tip, though exposed to different conditions than the sites within the bay. So this is begging for further explanation and experimentation. So I've pretty much rushed through this. I am going to say thank you very much to all the people and the organizations that have contributed to this, most especially WIOMSA and the Access Program for the early coral experimentation work, and to Simon Galiso and the Paul Wildlife Foundation for allowing us to work, and then for Carla's work to SIAB and SION. And I will leave more detailed information to the question and answer if anybody is interested. Thank you.
Thank you so much, Dave. And yes, as Dave mentioned, we hope to have a discussion and can also keep the conversation going on the OA information exchange, and that information will be in the chat box shortly. So now we are handing it over to Abraham. Who will be taking us to the west coast of Africa. Wonderful. We can see your slides, Abraham. If you would like to hop on video, you are welcome to.
Okay. How do I minimize the video? Okay. All right. Good afternoon, everybody. Okay. My name is Edworthy. Can you hear me?
Yes, we can, Abraham.
Okay. Thank you very much. Okay, my name is Ibrahim Bersi, and I'm a lecturer at the Department of Marine Environment and Pollution Control at Nigeria Maritime University. Okay, today I'll be speaking basically on OA activities in the West African sub-region. Okay, basically, I want to talk a little about my background. I think in January this year, I completed my doctorate. So I was basically pollution studies and remediation. So after that, I was telling myself, since I'm now working in a maritime university, what are the other areas I should begin to look into? Emerging issues in the coastal and the marine environment. So as I look at microplastic, PFAS, and ocean acidification, I think I was more interested in ocean acidification. So I started to look up materials in that area, and while I look up, there were very many confusing information. So I was trying to, say, hold on, am I sure about this? So I kind of back out a little, and then later I thought about, okay, let me look for networks or association within this area, and let me see if I can pick up from there. So that's how I searched, and I joined some of the network. I joined GOA-ON, and Dr. Mike was really, really helpful, introduced me to the peer-to-peer program, and he brought out a list of mentors, and I chose one, and before you know it, I have a mentor. And so far, we've had face-to-face meetings provided. She has also provided me, my mentor is Natalie Monashi, is at the University of Alaska. She has provided me relevant materials, has also notified me of any events that may be useful to me. Okay, for this presentation, I also, as part of reading up, I also try to look at previous efforts about ocean acidification within the African, particularly within the West African sub-region. And what I saw earlier efforts was on Ocean Data and Information Network for Africa, which is within Africa. And from the reports, I understand that they made effort to install about 19 tidal gauges around the different coastal countries in Africa. I think 3 of the installation was in West Africa, in Ghana, Senegal, and Nigeria. The one in Nigeria was in NOAA, Nigeria Institute for Oceanography and Marine Research. But basically, that program ended in 2009, and it was more of meteorological data collection. And since then, I think there's not really much effort about OA research in West Africa. Then also, I look up the OA Africa under the GOA-ON. And of course, I think let me just keep that information because Professor Nere have spoken about it from a slide. You saw the training in Ghana, in Senegal, and also the conference in Liberia. Also, as part of recent efforts, Ade Kumbi Falilu, who is a research officer at NOAA, got a funding from Ocean Foundation for his doctorate at the University of Lagos, and is looking at OA measurement in Lagos coastal region. Also, the OA Information Exchange, Dr. Kofi made mention of starting measurement of CO2 system in Côte d'Ivoire with the collaboration with Dr. Abed from Lebanon. And also Professor Edem released with his team, established the Biota Working Group. And also they have 5 aims that coordinates network of OA observation in the West African region, build capacity to undertake OA measurement, map out hotspots in member countries for OA monitoring, initiates OA monitoring member countries, and integrate the data they are collecting within the Gulf of Guinea into the global database. Then we had the summer school in Ghana, which took place between 3rd and 8th of August, organized by Professor Odem from University of Ghana and Professor Brian from University of Michigan. It was a very, very wonderful experience. We have great professors and doctors from the United States, Dr. Andrew, Dr. Chris, Professor Andrew, Professor Chris, and a great other experts. We also have Sam, Professor Sam, nice to see you again. Also, we have a lazy sound from Ocean Foundation. And I think it was a very exciting experience, but one of the things we realized is that so many people indicated interest, but at the end of the day, not everyone was able to follow through. I'm sure because of data and internet limitation, and also maybe the timing may not be too favorable to some others. And it was very, very fantastic or interesting. But like I said then, it would have been more better if it has been person to person summer school, because hopefully we would have been able to do some practicals on OA measurements and perhaps use of sensors within that summer school period. You know, within the summer school, that's what we realized, that within the West African region, you know, most of the research has not really taken place. It's like a black hole in the OA research landscape. And also, I looked at the ECOWAS maritime strategy, and the strategy 3 talk about environmental management, but it's just basically about oil spill, pollution related to the petrochemical industry, either in offshore or offshore across the West African coastline. There's no mention of ocean acidification or other emerging pollutant issues within the sub-region. Okay, coming from that summer school, Alexis told us about opportunity to apply for one-on-one coaching session with the Ocean Foundation. And we decided to build a team. We from the Nigerian Maritime University that attended the summer school, we formed a team together and we applied for that coaching session. I'm also aware that Falilo and others from the University of Lagos also applied for that coaching session, and they also got successful. And so far we've had Dr. Sophie. Next week we'll be doing the one-on-one training section. Sophie from Pacific Marine Lab in the United States will be taking us for the one-on-one training session. Okay, I just want to say a little about the Nigerian Maritime University, because our team at NMU are trying to draw out some little plan and outline of what to do moving forward. Okay, here you can see this is me, and basically the university is established in an island. It was established in 2015 and it took off in April 2018. The university is surrounded by seawater, creeks, mangrove swamp, and the open ocean. If you see here, this is where the campus, this is the first campus, Security Campus, located in an island here. Here, if you go straight, you enter into the Atlantic Ocean. And at this corner, you see there are two campuses of the school. The other one is at Okerenkoko. I think both campuses are like 10 minutes boat ride from one to the other. You begin to wonder, why is this school established far off the mainland? It's about 1 hour boat ride to the school. It was established as a result of agitation from minorities regarding environmental injustice. So that's why the school is established way off from the islands, about 1 hour boat ride from the island. Here is the Kurite campus of the university. So basically, we formed the Ocean Acidification Research Group. We also try 4 of us. Our names here from number 1 to number 4, we attended the summer school, so we also try to bring others. Fortunately for us, the first person, that is Dr. Bariwene Kibena, is our able dean of the faculty. The faculty have about 4 departments, and we felt there's need to bring people from various departments because we are all linked when it comes to the issue of ocean acidification. So we're trying to get other people that are interested to join us and form at least a better, formidable team to approach ocean acidification research. And we have a basic outline. We need training. We need to train ourselves, read as much as possible, start basic measurements, because from the information we got from the training we got from the summer school, there really needs to do something, to start something. Then from there, we'll hopefully enter into a monitoring program using sensors and all that, then advance to ecological studies, and there's need to do restoration and conservation way later, then we'll go into that. Then also we've highlighted some activities and schedules we want to do. when school resume, we may likely do a faculty workshop and seminar for the entire university on OA, acidification, research, and awareness. Then also we encourage people to join our team or create new research group, maybe people from fishery, climate change, and meteorology, if they want to create their own group or join our team, no problem. Then basically we'll kick off research efforts if we can have the necessary tools and the resources needed to do that. Okay, on my own from the summer school, I try to look at, I sit back from interaction with my mentor. I was just looking at it that since 1960, previous ecologists, Professor Igboge of blessed memory, Edworthy, and the others, they've been working on freshwaters and the saltwater region, water quality data, macrobenthic invertebrate community. So I said it would be good if I can compile, or if we can compile the water quality data and from the saltwater region, the creeks and the mangrove, and look at the pH alkalinity. The idea is to understand what has been happening within the past few years or few decades about the changing pH or carbon chemistry system, so that it can help us know perhaps how to plan or the kind of research design as we start to do any basic level measurement or monitoring. So we're also looking at funding and collaborators on this project, because collecting data, most of the data within the 1960s, 1970s may not be online. So we had to go across the 9 coastal states, federal and state university within these areas to get some of those data. I feel that it will help, try to understand the changing carbonate system, and perhaps give us the vulnerability if that's the issue within what has happened over time within the Niger Delta coastal region. Okay, research needs training. We need training because most of us are basically from a conventional environmental science background. We are just crashing into this area of science. So if possible, graduate and early career training for young lecturers, students, short visits from researchers from established OA, Ocean Acidification Research to university or Nigeria, or opportunity for us to go to established lab and also learn 1 or 2 things. Also, we need monitoring and data gathering tools. We need lab and field study tools. We need awareness and advocacy resources, and of course, research funding. Thank you very much for your time.
Thank you, Abraham. We will now head back over to the West Coast with Sam presenting. It should be coming your way, Sam.
Thank you. Let me know when you can see my screen. All right, so we are. Sorry? Okay. So sorry about the time is a little bit tight, so I'll try to focus on the message. And the message is basically wherever you are in Africa, you can start right now. I think we've been developing this capacity building program for a while now. So I was involved, you can see Kishore in the picture in the first training in 2015 in Cape Town, and where actually OA Africa started. It was officially kicked in 2016, and since then it's been like continuous support for Africa, from South Africa, Mozambique, Tasmania, Mauritius, Senegal, and so on. And it keeps happening. Like in 2019, you had 2, one in Kenya and South Africa, and one in Ghana. And I'm sure not everybody had the opportunity to join in all these things, but that doesn't mean that you can't start anyway. And something that was striking at the beginning of what I've done when I was doing this capacity building program was the challenges that you have to adapt to reality. And reality sometimes is that you don't have access to fancy lab, or you don't have access to lab at all. And you really have to adapt our strategy to make it work even in like simple conditions. And this is an example of a training we organized in Mozambique, where we basically started with an empty room, and within a week could develop like a functional lab with the ability to do carbonate chemistry measurements, but also a laboratory experiment. So it's possible. That's kind of my message. And you can use some of the simplified methodology, but even if you don't have access to this simplified methodology, you can already start to do something. What is important is to know where you start. And that's why in 2016, the IAEA set up a project called the IN project. And one of the first goals was to evaluate capacity. And a questionnaire was developed with a bunch of experts. And this questionnaire has been sent to different groups in the world, including in Africa. And that was kind of the summary of what we had like a couple of years ago. And we use this color code where red is the places where the challenges are the biggest, where you basically don't have stable electricity, where you don't have access to lab. And then the green being like you have more or less everything you need. But that doesn't mean that you have everything you need everywhere in the country. You can see the example here of South Africa, where it's a green country. You have labs that have everything you need, but you also have in some other labs red situation. So the usefulness of this kind of tool if evaluating the capacity is that first, you know where you are, you know what you can do, and two, you can also see where you can seek for help within your country or within your region. So that's really nice. I know we can see that within some region, you have some collaboration starting. But Africa is facing some challenges for sure, but there's also a lot of opportunities. You have a lot of support from the IAEA, from the Ocean Foundation, from many of the GOA-ON and so on. And you also have the opportunity of collaboration. You have a lot of energy. And that's really where you should really capitalize now. You should use this crazy energy that I've seen everywhere I've been in Africa and use that to actually create data and create knowledge. And it doesn't matter if it's not the fancier chemistry measurements, you can do things with what you have. And a good example is what happened within the WIOMSA project that Roshan mentioned. So you have these 6 countries that received some seeding funds, and not so much in some of the countries, and they don't have much to start with, but it's enough to actually start something. And Dave, that we presented a little bit earlier, used this grant as an opportunity to organize a training. So we all gathered together, like people from some different countries within the WIOMSA network, to basically do an experiment together. And I can tell you, it was nothing really fancy. We did a simple experiment, but within a few days, we were able to collect data and actually test quite complex questions. So we compared 2 populations of the same sea urchin species, did a wide range of pH, and tested like using a simple assay, which is a fertilization assay, if we could see local adaptation, and we could. So we had a beautiful, simple data set within a few days with limited resources. We applied again the same concept, like doing simple experiment with very little in Kenya a few months later, and again could collect data within a few days. And we could add another curve to this using the same species and testing a complex hypothesis. So my message here is, sure, we all want to do complex thing and go outside and measure carbonate chemistry with the better quality, but it's not going to happen for most of you in the short term, but you can still do really good stuff. And if you're interested in this, we've built a best practice on how to do biological experiments that are really valuable for your region with very little. Basically, what you need is a few petri dishes, seawater, a bottle of CO2, and a microscope. And if you have that, you can basically test really interesting hypotheses. And we developed this fertilization assays protocol for you that is open access, so we can send it to you if you want. And just to tell you that it works, like I had an email today from Daniela from Mozambique saying that they were using the protocol and they were actually starting experiment themselves now. So you can see on the picture them working on using a fertilization assay just a few days ago. So it works. So basically, don't get stressed by the fact that you have very little. Use what you have and you can actually start collecting really good data. And there is a lot of support out there, like through the peer-to-peer program, through local colleagues and so on. Another thing that you can do is you don't have access to fancy lab is actually use data that are already there. And that's something that actually I experienced myself because of the COVID-19 restriction, I didn't have access to my lab for a few months. And I realized that that was putting me in the situation that many developing countries are facing, is like not having access to fancy labs. So what we did is basically took advantage of the literature. So together with colleagues in Chile, Christian Vargas, we basically digged into the literature and used the existing data to create new knowledge and test new hypotheses. So we basically took an idea that we published a few years ago in this paper and applied it to the existing literature. That's also something that you can do. So you don't necessarily need to create new data to create new knowledge that can be useful for you. You can see what has been done on the species that are critical in my country, in the ecosystem that I know, and what can I already know before starting experiment. So Africa is a land of opportunity. You have a lot of things that you can do with whatever you have today. And that was kind of my message for today. And just to show a success story, I will tell you a little bit about Carla. Carla that actually saw some of her results in Dave's presentation, but basically she had her first contact with OA in 2016 in the Mauritius training that has been organized by the Ocean Foundation, GOA-ON, and so on, and hosted by Roshan. That was really the first contact. And within 4 years, she started from like people starting to learn about the problem to somebody who's actually an expert now. She's been trainers in a different capacity building program, and she's now about to defend a really great PhD thesis on that piece of fish, where she started from scratch, from going in the field, doing monitoring, design beautiful experiment on fish, and making really fancy experiment on metabolic physiology, on swimming activity and feeding behavior, and so on. So it's kind of a beautiful case study on how things should be done if you start in the field. So that was it. I made it extremely fast to save some time, but basically Africa is a land of opportunity, and there's a lot you can do with whatever you have. And feel free to contact me, contact us if you want some more information. Thank you very much.
Thank you so much, Sam, for that little bit of inspiration. We will go ahead and hand it over to our final speaker, Mario. Perfect, Mario. We can see your slide.
And can you hear me now? Eh?
Yes, we can.
Okay, thank you so much. Okay, I'm going to present a new initiative we have running in the Indian Ocean in Mozambique. It's the BCSS Ocean Observatory. BCSS stands for also a new marine research station in the Bassarutto archipelago. And I'm quite excited to present this to you guys and the community, because this basically opens a great opportunity for the region, regionally, nationally, internationally, especially for collaborations for students. And it builds a little bit from the presentation from Sam, that you arrive to an empty room, an empty place, and you just build from that onwards. And in this particular case is the reality. We'll be building from an empty room pretty much from the last 3 years. So basically, in 2 sentences, who we are an innovative platform hosting a permanent ocean observatory that's focused on multi-ecosystem time series in Africa, basically in the Indian Ocean. By multi-ecosystem, I mean we run in time series permanently in coral reefs, seagrass, meadows, mangroves, and the open ocean, and we touch a few other ecosystems as well. And our purpose basically is to support local communities and local collaborations, but basically to be of appeal as well for the international audience. Just in case you wonder where this ocean observatory is located, we are in the Bassarutto archipelago, which is a national park. It has a few islands, and it's a very, very convenient place for this kind of studies, because ecosystems and habitats that all of you study or that are of concern internationally are located within a very short distance. So you have your coral reefs, seagrass, mangroves, open ocean, deep waters, even coastal towns to study, for example, anthropogenic direct impacts within 10 to 20 kilometers. So it's very practical. Just in case you wonder the kind of setup we're planning and we have already been pushing, It's a mixture between what's running in Bermuda in Bath Station. It's also a combination of that with what's happening in Hawaii and Aloha, and also a combination a little bit with Kaukofi. So we've basically taken several ideas from other observatories that are permanent and time series mode year round, and we've combined it for the Observatory Archipelago and Mozambique into a multi-ecosystem. So the novelty, if you're wondering what's novel here in terms of time series, in particular applied to ocean acidification, is that there is work in parallel in all the ecosystems, and I will show you towards the end of the talk. The data will be available to the community, and that's why we have joined GOA-ON. We made contact, and immediately they say definitely you guys need to join. So that's mainly the reason we joined. Just to quickly run you through what's happening in the station. It's a bush station. It's quite advanced though for the remoteness of the place. We are in Benguera Island, which is honestly quite isolated. We have basic laboratories with microscopes and some machines, centrifuges, ovens, and a few other basic things to do to process your samples. There is accommodation as well. And then basically our main focus is around getting good quality data and combine it with collaborations, do ocean research, and also at the end of the day benefit local communities there. Just trying to focus a little bit more to talk towards the ocean acidification. We have some themes we developed in the Ocean Observatory, which go around ecosystems and spatial mapping, and then we also work with migratory animals. But at the end of the day, the main focus of the observatory is to provide that metadata that sometimes is quite hard and costly to obtain. And also Sam mentioned it in the talk, you don't necessarily sometimes need to go out to try to get all this permanent and continuous data, because it might be too expensive, the funding might not be available. But in our case, we want to make, for example, all this data open so people can use it. So for example, you might be working, I don't know, on corals on the region, or you might be working on migratory fish, or you might be working on something that might have relation to ocean acidification, and you might not have that capacity to get this oceanographic data. So this is a place, if you are working reasonably close, you can get your metadata without going out there and spending thousands of dollars to get your data from the ocean. I'm talking of complex parameters like alkalinity, or DIC, or nutrients, or I don't know, dissolved metals, things like that. Within the observatory, we have volunteer and intern programs which help to run all the work to do, which is it goes quite beyond just sampling seawater and taking water samples. There is a lot of other things going on in parallel. Obviously, we have moorings and some sensors, so there is maintenance, there's a lot of technical diving. But at the end of the day, all the programs go around the observatory, and even if they cover different topics, they again, as I said just a minute ago, the aim is to focus on getting that data and make it publicly available. Just to show you some of our infrastructure and how, again, coming from some photos of that empty lab, we also had an empty, I don't know if this is a lab. This is not a lab, it's like a warehouse, but it's very basic, and I definitely acknowledge those comments of research sometimes in Africa, especially oceanography or operational oceanography. It can be quite complex. If you are in Mozambique, for example, I know South Africa is it's not a little bit more advanced and has more capacity than obviously Mozambique. So it's quite a challenge to just get the gear there and get it ready, and there is a lot of engineering around it. And luckily, we have a lot of talented African and Mozambican people that are engineers, electricians, and that they know even to weld. Just to weld in a place like this is a premium. So we've built together some benthic landers and some of the permanent moorings to attach sensors. There is those are not Niskins, those balls on the back. They are, I don't remember the name. They are similar to the Niskins. And just to put you quickly on some numbers of what we've been doing for now, and we have some hydrophones deployed because there is interest on recording sound and compare it with ocean acidification parameters, so to couple the sound and the water sound with pH and temperature. We also deploy some receivers to pick up tags from sharks or migratory animals. We do some remote sensing from temperature and chlorophyll, and that data also will be available for people. At the moment, we have 2 to 3 years of data from that particular work on remote sensing. Then on one of the other themes we've already mapped 9 different habitats. We have a lot of hours monitoring already. 12 murines have been produced, and we are deploying, redeploying, maintaining already. There's a lot of spatial mapping also for different species, endangered taxa. But at the end of the day, we don't want to record this animal just for recording. We want to link it to the metadata we will generate, being related to ocean acidification or not. That's a different question. And eventually, we also work with migratory fish, which it's not obviously related to ocean acidification, but well, you can always at some point relate if you have the metadata. So, okay, I'm gonna go now into the specifics of ocean acidification per se, which is what most of you are interested at. I thought, to show you also the other opportunities around this observatory. So in the GOA-ON website, you have this map, which is the official map for now, where we have the observatory moorings on the Bazaruto archipelago. I have to say they are not all of them are the official locations. They're gonna change because we're gonna do another round of deployments. I don't know if end of this year or beginning of next year, but we've been doing a lot of trial and error with several things because the area is very, very complex for these semi-deep water deployments, and the currents are extremely hectic here. And basically, the setup you can see in the sketch is a heavy ballast at the bottom. There is a frame for a camera and a light system, so we can record also live video photos for events. And then there is the typical ocean observatory setting with a rebar and a rope and a buoy where you can attach different sensors, being receivers for animals to pick up animal signal, or pH sensors. At the moment, we have hobbles there for temperature and light, but you can attach anything. So this platform is open for collaboration for people. We are happily taking care already of 3 other external people projects in terms of maintaining their sensors and sending them the data. We obviously maintain also ours, but I reiterate, this is open for people to communicate and with us and join, and there is no fees to put stuff with us, so there's no cost unless you want to come and obviously do research in the station. So we are quite open for collaborations here. Most of this is privately funded, and we have the freedom to choose. Just to quickly give you a range of measurements in terms of how often they happen. We do have continuous, the daily remote sensing. We have the bottle samples for alkalinity, DIC, dissolved metals in seawater monthly. Maintenance is quarterly, and the analytics, we're aiming for 6-month timeframes. But you all know it's complex to work with these things in Africa. So sometimes, shippings or exports or imports delay these things. So there is no compromise really on the delivery of results. That's totally out of our control normally. I'm trying to advance a slide here. Okay, so just in case you're wondering what kind of elements or data you will be able to get from this ocean observatory when it's fully running, which, as I'm saying, I think is going to be early next year. You're talking mostly of sea surface temperatures and sea bottom temperature, mostly for coral reefs, light levels, salinity, total alkalinity, and dissolving organic carbon measured from 250 milliliter bottles. Then I guess we will work out the pH carbon system variables with software, nutrients, major and minor elements, and dissolved oxygen. A few of these will be taken with YC probes that when we arrive to the station, not all of them obviously will be taken continuously because many of them need to be bottled and other need to be done with a probe. And then there is plans for some plankton towels sporadically, and I'm thinking that on that front for plankton, we obviously cannot get into the detail of something like coffee, which is extremely detailed, and mostly we're going to give likely things like carbon composition or measurements of isotopes. It hasn't been decided yet for plankton. How data is going to look, you can see it on the right side of the screen. This is a snapshot from another time series we've been involved before in Bermuda. This is from a paper that was published on coral reef ocean acidification and temperature effect on coral reefs during 3 years, continuous and semi-continuous measurements. So we've already have a lot of training and expertise on it, and I'm aiming for BCSS to be able to provide this kind of data. I don't know if in this complexity, this was quite expensive project, but that's the aim at least. And the map you can see in the middle, it's more realistic of where the stations are. And on the middle, on the legend, you can see a little bit what kind of ecosystems. It's so red dots is coral reefs, green seagrass, brown is mangroves, a blue out in the ocean is an offshore, which is within a canyon, and well, the rest I've explained it already. And I'm going now towards the end, and just something for interest for all of you. The metadata in our case is going to be joined with some wildlife mapping work we're doing. So we want to join all these parameters when they are ready in time series mode after a year with where animals are sitting in the archipelago, where are they moving, how are they using the seabed. We also have 3D seabed capacity equipment on the boat. So we want to push a little bit things beyond just measuring the conditions in seawater. We want to start, joining to animal movements and where things are, why things are there. And definitely on all these things, we welcome people that are interested in collaboration, because as you can imagine, this is complex, dense, and expensive. And just going towards the last slide on data, which probably most of you will have interest on this at some point. The data from the Ocean Observatory is going to be available. It's not available yet. Some is on demand. If you ask me about things like temperature for the last 3 years and some light measurements, but the other interesting data, the chemistry, carbon chemistry, it will be available on a platform on our website. That this will be announced, and I'm expecting it'll be an easy interface. You can come in, you can search what kind of data is available, and you can put a request, and somebody will come back to you and discuss. Or if you can download directly, if we stipulate that you can download directly, you will. So this will be available. I don't have a deadline, honestly, but we think sometime next year this will be available. But you can imagine, to get the bulk for alkalinity, DSC, and other things needs to come back from analytics. So we're talking of a long-term project here in general for the Ocean Observatory, and we really hope it can help some of you or some of your colleagues if they are working on the region. And as I say, we welcome collaborations at any level: regional, local, national, international, students, and kind. We're very happy. We've talked to many people already, and we are very open and young team. And I don't know if I've gone over time. I've tried to go quick, so I thank you for your time, and I'm looking forward to discuss with you all.
Thank you very much, Mario, and thanks to all of our speakers. We are now going to, we do just want to be mindful of time. We have gone past the hour, so we will just ask all of our panelists to come back for one question for the panel. Totally recognize if any participants do need to head out, and do encourage you to go ahead and keep the conversation going on the OA Information Exchange or on Twitter. I know we have conversations going in both of those places. So as our panel gathers, I will let others join. Great. So we will wrap up the presentations, both start and end the conversation with what I think will be a great opportunity for each of you to possibly speak to your perspective. So this question came from Carol Churley, and it was, if you could each speak to perhaps the next steps and maybe a longer term goal for you, for OA Africa, that would be lovely to hear from each of you. Not sure if someone is muted.
Do you want to go in order, or?
Yeah, take it away. I'm having I cannot see your faces, so you all can.
Okay, thanks guys. Thanks for the question. In terms of the longer term, I think I have to echo Sam's point here about collaboration and connection. We have struggles in Africa, in some regions more so than others. I think the critical point is that we really have to work together. And some people have location, but not the facilities. Other people have facilities, but not access to locations quite as easily. So there's a lot we can offer each other, and that's my take home is that just as we've been working with Carla and working with Mozambique, etc. And that's why this last talk with Mario was so great, because he's so open to collaboration and cooperation that I think that's an excellent opportunity. So that's my take-home message, and I would invite everybody or anybody that's interested to contact me, and we will, if you need help, access to information, or if you just want to talk about collaborating, we are always open to new ideas and to new opportunities.
Thank you, Dave, for that response and offer. Roshan, would you like to chime in here?
Well, I think it's been a very fruitful session. I mean, trying to get, just to get the networking through the webinars. I mean, especially connecting with African countries and getting all the hubs together and learning from different projects and experiments which have been done. I mean, this is quite, especially after the COVID-19, where there has been like a probably 2 or 3 month break from February or March. Even in Mauritius, we had a complete lockdown where people couldn't go out on the field. So, this we start building up the synergy and experimental things, especially, in terms of equipment, in terms of getting back to some of the lab work and so on. So I guess, in OA Africa, where we are focusing on capacity building and networking and developing the OA website and trying to attract funding and trying to get our ocean acidification in various policies, in various committees at national and global level, especially national levels. These are challenges we're facing scientists, African scientists in Africa, especially West Africa, North Africa, East Africa. And as I said, these are very important projects that we are developing at the pilot stage and trying to build up probably in the years to come, learn from various hubs what type of experiments. Hopefully scientists in various biological or chemical or combine together and try to build up experiments. That would probably be the next step for OA Africa as well, because we are meeting bi-monthly at the steering committee level, trying to discuss what would be the various stages for various countries as well, because some people are, I mean, in East Africa, we are quite fortunate to be able to have some of the projects ongoing, and hopefully we can serve as an example or a model for various regions as well. I mean, it's quite useful, especially with the technology, with the ISAMIs and various experiments which are being built up. And I guess, I mean, each one, we are at the equator at the tropical level, and where the pH is always 8.2, 8.1, 7.8, not as the places in the Arctic or polar regions which are facing. And this is where we got to learn from this. I guess this would be my comments. Thank you.
Thank you, Roshan.
Yes, I can say a few quick words if you want. So basically, I think Africa in many places is starting, like it's been starting for several years in some places, but in some other it's just the very beginning. And I think what is important is to prioritize. I think that's also something very important. When you work with constraint, you have to be efficient. And what I mean by that is that lack of data on ocean acidification is not a problem. Ocean acidification is the problem. So if it's not all data that are useful. We don't need to know everything about everything. So I think a real prioritization of actually what kind of data is needed to tackle the problem is really what needs to be done. So in a way, it's great because when you start, you can actually do it better. And we as scientists, we tend to be curious. We want to know everything about everything, but we don't have the luxury of time. So we should not have a too long-term plan because we need to fix it as soon as possible. So in a way, use the mistake that have been done everywhere else to actually make it more efficient would be my recommendation and my vision for the near future is what are the real data that we need to implement solutions. That could be influence policy, that could be adaptation, how to protect the ecosystem in the best way, or to capture carbon. There are tons of things that can be done.
Thank you, Sam. I see some head nodding. Kishore, Abraham, Naira. Kishore, I believe you're still mute. If you'd like to find the microphone so we could hear you. I believe you're muted.
Sorry for this, I forgot to switch this on. Yeah, I was just thinking about the National Observatory we are coming up with, I think in joint collaboration with MOI. So I think MOI is more to do with the outer islands. So in a way, if we can contribute to come up with data in what we are like collecting in lagoons and outer islands, that would really help when we are going to conduct like biological experiments. Especially Sam Dupont is an expert in the field, so he can help us with that. So we're very, very grateful to him. So yeah, to go ahead with the biological experiments. So,
okay, thank you very much. I think I've really learned a lot today, especially from Kishore's presentation, you know, measurement of pH and added some other few parameters. Like what Dr. Sam has also said, you know, we can't just say we have to start from somewhere. And I'm very optimistic that although we have our internal constraint as a new university, you know, infrastructure projects are still ongoing and stuff like that. But I'm very confident that after the lockdown, we'll be able to start something. And, you know, at the basic level, you know, let's get the vital information we can get, even if it's pH measurements, you know, at a daily or monthly level, and begin to start from there and then move upward. I think we'll do that. And of course, I have very senior people to call on: David, Sam, Kishore, Roshan. Yeah. I'm sure we'll be disturbing you guys a lot. So just bear with us, and because when we run into issues or we try something, it didn't work out. You know, I'm really encouraged by what Sam said. you know, from his experience and from the feedback he's getting. So I think we are not just going to sit and say, oh, let's wait to get these, or we need to know this. Definitely, we are going to start from somewhere. Thank you.
Thank you, Abraham. Naira, it's very fitting. We lost you in the beginning, but we'll let you have the final remarks. I'm so glad you're back.
Okay, hello everybody. I just want to thank my panels for their valuable conversation and valuable presentation, and thanks the attendants who joined our webinar. Thank you very much, and I can say more than my colleagues said, my colleagues in the panel, and I totally agree with Sam that we need to start. It doesn't matter what we have, but actually we received a lot from the funding agency, from our mentors, from during the last, the previous training and workshops and capacity building programs. So we need to cooperate, work together, start in a project, and start studying and focusing on impacts of ocean acidification on biology and habitats. Thank you. Wish you all the best. Stay safe. Thank you. Goodbye.
Thank you all. Thank you, speakers, for your wonderful presentations, thoughtful remarks, all of our attendees for sticking with us. And we may see you at the next session. We'll be focusing on Latin America and the Caribbean in just a few hours. Thank you all.
Bye. Thank you very much. Bye.
Thank you.
Thank you.